Hey, welcome back. We're here in Chapter 5. In Chapter 5, we're going to have three sections, and it's all introduction of probability. So we're going to talk about randomness, probability, and simulation here in Section 5.1 is what we're going to be doing. So let's get ready to rumble. Here it is, our learning targets. We want to make sure that we interpret probability as a long-run relative frequency, and we want to be able to use simulation to model chance behavior. All right, here we go. Whoops, we don't want to cancel that. All right, so a random process generates outcomes that are determined purely by chance, and a trial is one repetition of such random process. So we can kind of see here, as we look at the graphs here, the proportion of heads in the first 10 tosses. Okay, so 10 tosses, those are what we have. And then, of course, the proportion of heads in the first 500 tosses of a coin are listed here. Okay, so the probability of any outcome of chance process is a number between 0 and 1. Of course, 0 meaning it can't happen, 1 that it's definite. And that describes the proportion of times the outcome will occur in very long series of repetitions. So you can kind of see the tossing of a coin there. All right, the law of large numbers says that if we observe more and more repetition of any chance process, the proportion of times that a specific outcome occurs approaches its probability. Doesn't mean that it's going to guarantee to get there, but the more of them you do, the closer it should get to its actual theoretical probability is what it should get to. Okay. Now, some people distinguish between tossing a coin several times to estimate the probability of a head, empirical probability, and using a computer applet to simulate this random process. So you can do random numbers, you can do all sorts of there's all sorts of simulations out there that you can use. All right, so let's talk about randomness. The idea of probability is that randomness is predictable in the long run. Unfortunately, our intuition about chance behavior tries to tell us that randomness should also be predictable in the short run. You know, people always say, oh, if I flip a coin 10 times, I should get 5 heads. Well, not really. You'll get 4 or 6, you'll get all sorts of them. It doesn't mean that you're guaranteed to get it. Now, the more of them you do, the closer you should get to a half heads, but that's kind of misguided beliefs, as we say. Some people use the phrase law of averages to refer to the misguided belief that results of a chance process have to even out. So they'll be like, if they get 3 heads in a row, they'll be like, oh, the next one should be, guaranteed to be a tails because it's going to balance out. Well, no, it's still 50-50. In the long run, we should be able to get there, but in the short run, not necessarily. Now, simulation is the imitation of chance behavior based on a model that accurately reflects the situation. We do a lot of things with drawing cards, flipping a coin, spinning a spinner, all sorts of different things. And so what you want to do is describe how to use the chance device to imitate a trial, in other words, a repetition of the simulation, and tell what you're going to record at the end of each trial. Perform many trials of that simulation, and then use your results of the simulation to answer the question of interest. Okay, so we've got a case here where, in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of the following NASCAR drivers: Joey Logano, Kevin Harvick, Chase Elliott, Danica Patrick, or Jimmy Johnson. Now, the company claims that each of the 5 cards is equally likely to appear in any box of cereal. A NASCAR fan decides to keep buying boxes of cereal until she has all 5 drivers' cards. Seems to be something familiar for me, what we used to do in our cereal boxes all the time. I don't know if they still do this, but we used to love getting the little things, digging in the cereal, getting the toy out of there every time we get to open a box. Now, she is surprised when it takes her 23 boxes to get the full set of cards. Does the outcome provide convincing evidence that the 5 cards are not equally likely? To help answer this question, we want to perform a simulation to estimate that the probability that it'll take 23 or more boxes to get a full set of 5 NASCAR collectible cards. So we're going to set up a simulation. All right, so we want to describe how we would do that. Well, what we could do is we could let 1 be Joey Logano, 2 Harvick, 3 is Chase Elliott, 4 is Danica Patrick, and 5 is Jimmy Johnson. And then we can get the random number generator on our box, from our calculator, and that would simulate buying a box of cereal and seeing what's in there. And then we would keep generating random integers until we get all 5 labels from 1 to 5, and then we would record, well, how many boxes did we have to buy to get that? All right, now again, if we have the dot plot here, we can see here that if we have a 20, that means it took us 20 boxes to get all 5 drivers' cards. Okay, now using the results of the simulation to estimate the probability it will take 23 or more boxes, well, Yeah, here it is. It looks like we have two, or no, there was actually zero. I guess that's a 22. Those are at 22 right there. Probably is at zero of our simulations. None of them took 23 or more, and because of that, we're probably saying, yeah, chances are they're probably not like equally spread because we didn't even get that. Now, if it would have been something like 15 or 13 or something like that, we'd say, well, yeah, okay, that's possible. But because of all of our simulations, we never took 23 or more, we're a little skeptical that they were evenly distributed. So again, we're running the simulations, and there's all sorts of ways to set that up as well. All right, so again, in this section, we should be able to interpret probability as a long run relative frequency and then use simulation to model chance behavior. And there's some great exercises that we'll have, and that wraps up 5.1. And until next time, I'm Mr. Boone.